Students, welcome to our video lecture. Today's lecture is basically involving all theories. And if you understand this perfectly, then and then students, you can understand the definition of limit. Now, today we are going to discuss the meaning of x tends to 1. This is read as x tends to 1. This arrow indicates tends to 1. Means what? This is best understood with the help of a number line. Say students, I draw a number line. So this is integer 1. So this is 0. And say this is 2. Now, students, on the number line, we can approach 1 from two sides. This is from left hand side and this is from right hand side. That much all of you must carefully understand. Today, students, we are going to understand the basic theory on a number line. A number can be approached from two sides, one from left hand side and one from right hand side. I can approach one from left hand side as well as from right hand side, only two sides. Say, first I take x as 0.9, then I can take x as 0.9, then I can take x as 0.999. Slowly and slowly I am coming towards 1 from less than 1 towards 1. 0.9 less than 1, 0.99 less than 1, 0.999 still less than 1. So we are approaching 1 from less than 1 towards 1. Means slowly I am increasing this value of x. Check. 0.99 is greater than 0.9. 0.999 is greater than 0.99. Again, if I take 0.9999 is greater than 0.999. So slowly by increasing x, but I am approaching 1 from left hand side, less than 1 towards 1 by increasing the values of x. If I am approaching from right side, then I can take x as 1.1, x as 1.01, x as 1.001. Slowly I am decreasing the values of x, and from right hand side, students, I am approaching 1. So on a number line, the real number 1 can be approached from two sides. One is from left hand side, other is from right hand side. When we are approaching from left hand side, the values of x goes on increasing, and we are approaching 1 from right hand side, the values of x goes on decreasing. This much only, students, we have to remember. So on a number line, any real number can be approached from two sides. One is from less than that number towards that number, and other is greater than that number towards that number. When we approach 1 from left hand side, the value of x goes on increasing, and when we approach 1 from right hand side, the values of x goes on decreasing. So students, this is the meaning of x tends to 1. So how to write, students, this in terms of theory. Say, what is the meaning of x tends to 1? If the values of x are brought very close to 1, if the values of x are brought very close to 1, either by increasing the value of x or by decreasing the value of x, then we say that x tends to 1. Then what do we say, students? X tends to 1. I repeat, according to textbook, if the value of variable x is brought very close to 1 by increasing from left hand side, it is by increasing this x or by decreasing this, then we say that x tends to 1. And it is very important to understand that when I say x tends to 1, it never means that x is equal to 1. Students, when I speak x tends to 1, it never indicates that x is exactly equal to 1. So, very simple. On a number line, one real number can be approached from two sides, from left hand side as well as from right hand side. When I approach one from left hand side, values of x are increased, and when I approach one from right hand side, please remember the values of x are decreasing. When you go like this on the number line, when you go from left to right, x increases, and when you go from right to left, x decreases. This is what, students, we have to understand. Check in the textbook. Now I am reading. Students, what is the meaning of x tends to 0? Okay, first of all, let me explain what is the meaning of x tends to 0. So let us write this is x tends to 0. Draw the number line. So this value is -1, this is 0, this is 1. Now you can approach 0 from two sides. One is from left hand side, one is from right hand side. So when I am approaching 0 from left hand side, then you can check this value. X is first is -0.1. Then I write this as -0.01. Go on decreasing, then I write x is equal to -0.001. Like that, students, we have to write it. And when I approach from right hand side, suppose x is 0.1, then I am decreasing and writing 0.01, and I am writing 0.001, like that. So very simple, you can approach 0 from two sides. One is from left hand side, other is from right hand side. Now when you approach 0 from left hand side, x goes on increasing. Mind you, here is the -0.1, then this will be -0.01, this will be -0.001, -0.0001, like that. So whenever, students, whenever you are approaching any number from left hand side, on the number line, when you go from left to right, x increases. When you go from right to left, x always decreases. So, check the meaning of x tends to 0 is given in textbook. If by decreasing the positive value of a variable x or by increasing the negative value of a variable x. Here I am increasing the negative value of variable x, and here I am decreasing the positive value of variable x. The value of x is brought very close to 0. Then we say that, students, x tends to 0. It is necessary to note that in x tends to 0, students, x is never taken as 0. X is very close to 0, but x is never equal to 0. Here, x is very close to 1, but x is, students, never equal Now, a generalized approach for x tends to a. Say, this is the number line. Say, this number is a. Say, this number is a plus 1. Say, this number is a minus 1. Now, students, we can come towards a from two sides. One is from left hand side, other is from right hand side. Clear? Now, when we come from left hand side towards a, the values of x always increases, and when we come from right hand side towards a, value of x always decreases. So when we come from less than a towards a, means when we come towards a from left hand side, check always x increases. And when we come towards a from right hand side, always you can say the value of x decreases. So when we are approaching from left hand side, the corresponding value of x always increases. And when you are approaching a from right hand side, the corresponding value of x always decreases. So what is the meaning of x tends to a? I read from textbook. If the value of variable x is brought very close to a by increasing, so from left hand side, or by decreasing the value of x, then we say that students x tends to a. And it is very important and clear to note that when I speak students x tends to a, then x is never mathematically students equal to a. When I say that x tends to a, students, x is very close to a, but still students x is never equal to a. When I say students x tends to 1, x is very close to 1, technically x is never equal to 1. When I say x tends to 0, x is very close to 0, but x is never equal to 0. In general, when I say x tends to a, in general, when I say x tends to a, x is never equal to a, even though x is very close to a. So this is the meaning. I am reading from textbook, students, to make you understand. Please pay attention. This is the basic for the definition of limit of a function. The meaning of x tends to a. If the value of variable x is brought very close to number a by increasing, means from left hand side, or by decreasing the value, then we say that x tends to a. It is denoted by x, that arrow, and a. By increasing the value of x, means from left hand side, and by decreasing the value of x, means from right hand side. These are the key words, students, which you have to memorize. Which are the key words? X tends to a. When the value of x is brought very close to a by increasing, means from left hand side, and by decreasing the value of x, means from right hand side, then we say that x tends to a. It is to be noted that x tends to a means that the value of x approaches very close to a, but it will never be equal to a. Then in textbook they have given students the meaning of x tends to 0. If by decreasing the positive value of x, decreasing means always from right hand side, or by increasing the negative value of variable x, x is brought very close to 0, then it can be said that x tends to 0. So when I am approaching from left hand side, again I am repeating, x always increases. This negative value is increasing, and this positive value is decreasing. So when we approach 0, either by increasing negative value of x or by decreasing positive value of x, then we say that x tends to 0. It is necessary here to know that x tends to 0 means the value of x approaches very close to 0, but technically it is never equal to 0. Now students, we are going to study the definition of limit of a function. Students, we are going to understand this with the help of an example. So I wish that all of you perfectly understand the definition of limit of a function. Now students, we are going to study the definition of limit of a function. Definition of limit of a function. Now, here also let us demonstrate the fact with an example. Say our function is fx is equal to x plus 1. Now function we have studied students in standard 11, our chapter number 8. Let us suppose that our function is fx is equal to x plus 1. And x approaches any real number a, say x tends to 1. I can take 2, I can take minus 1, I can take root 2, I can take 3 by 5. X approaches a can be any real number. As per our example, I am taking an easy number, say x tends to 1. Now just now we have studied that x can approach 1 from two sides. So if I draw the number line, say this is 1, say this is 0, and say this is 2. X can approach 1 from two sides. So suppose I take x is equal to 0.9. So here somewhere, isn't it? Then what is the f of 0.9? It is 0.9 plus 1, which is how much? 1.9. Then students, I take x as 0.99. Then what is functional value at 0.9? 0.99 plus 1, so it is 1.9. Suppose x is 0.999, then f of 0.999 is 0.999 plus 1, it is 1.99. Clear? Observe this rhythm. 1.9, 1.99, 1.999. Okay, so when x approaches 1, from left hand side means by increasing the value of x. Check. From left hand side means by increasing the value of x. Okay, now taking from right hand side. Say suppose x is 1.1. Then f of 1.1 will be 1.1 plus 1. So 2.1. Now 1.0. So f of 1.01 will be 1.01 plus 1. 2.0. Say this is 1.001. F of 1.001 is 1.001 plus 1, and that is 2.001. Observe this rhythm. From right hand side, so x is decreasing. From left hand side, so x is increasing. Check this answer. 2.1, 2.01, 2.001. If I observe students, there is 6 boxes. Now 1.999 is close to what? 2. Even 1.99 is close to what? 2. 1.9 is also close to what? 2. 2.1 is also close to 2. 2.01 is still closer. 2.001 is still closer. So, as x approaches 1, either from left side or right side, the functional value approaches 2. 1.999 is also closer to 2, and 2.001 is also closer to 2. So what can I say? What can I conclude, students? That as x tends to 1, then functional value f of x tends to 2. Therefore, the limit of the function as x tends to 1, this is called limit as x tends to 1 of x plus 1 is approximated as 2. Exact 2 is never the answer. The limit is close to 2. So as an approximation, I am writing 2. Technically 2 is never the answer because x is never 1. Because x is never 1. So now I am reading the definition in terms of this example, students. We try to understand. When the value of x is brought closer and closer to a number a, here it is number 1. First of all, I am trying to explain the definition in terms of our example. When the value of x is brought closer and closer to 1, the value of function f of x reaches closer and closer to a definite number 2. Yes or no? When the values of x are brought closer and closer to 1, the functional value f of x is brought closer and closer to a definite number 2. Then you can say that as x tends to 1, then f of x tends to 2. Therefore, the limit of the function as x tends to 1, x plus 1 is approximated as 2. 2 is never the answer, but as an approximation of 1.999 or 2.001, we write the approximation as 2. So now, what is the definition? I am reading the first definition of limit of a function, students. There are two definitions of limit of a function. Today we are going to discuss this first definition, and after we complete exercise 3.2, we are going to refer the second definition of limit of a function. When the value of a variable x is brought closer and closer to a number a, then the function f of x is brought closer and closer to a definite real number L. Here, as per our example, it is 2. Then we can say that as x tends to a, the functional value f of x tends to L. Symbolically, it is written as limit x tends to a, f of x is equal to L. L is called the limiting value of the function. This I can write, students, like this also. Limit x tends to a, fx is approximated as L. Compare here. Then a becomes 1, our function becomes x plus 1, and our answer becomes a. Exactly it is not 2, but it is approaching 2, so we approximate it and write it as 2. So what is, students, the definition of limit of a function? All of you focus on this example. When the value of variable x is brought closer and closer to a, as per our example, the value of variable x is brought closer and closer to 1. X can approach 1 from two sides. One is from left hand side, there is from right hand side. So I say, when the value of variable x is brought closer and closer to a real number a, the function f of x is brought closer and closer to a definite value L. Therefore, as x tends to a, f of x tends to L. So L is called the limit of the function. As per our example, as x is approaching 1, f of x is approaching 2. Not exactly 2, but it is approaching 2. But as an approximation, we write the limit as 2. So symbolically, limit x tends to a, f of x is equal to L. So this is the first definition of limit of of a function. Once again, I am repeating, write this definition thrice, and today's theory is also thrice. Last and final time, students, the definition of limit of a function. When the value of variable x is brought closer and closer to a real number a, f of x comes closer and closer to a definite real number l. Therefore, as x tends to a, f of x tends to l. So l is called the limiting value of the function as x tends to a. Symbolically, it is written as limit x tends to a, f of x is equal to l. A is any real number, l is also any real number, 1 is also a real number, 2 is also a real number. So this is, students, the concept of definition of limit of a function. So try and understand this theory, students. Throughout exercise 4.2, I will be discussing and when we do the sums again this definition, but it is not at all difficult to understand. So we can approach A in two ways: less than A towards A from left hand side. When we approach A from left hand side, x increases. When we approach A from right hand side, x always decreases. This is the key word, students, which you have to memorize. So here we conclude the lecture, students. From next lecture, we will do exercise 4.2. I told you there are two definitions of limit. This was the first definition, still second definition also will study, but that I will teach along with exercise 4.2. Thank you, students.